this is a circuit diagram of a SR latch using NAND gate, and this is its truth table. So these are the inputs: S input, R input, and these are the output Q and Q bar. Here 4 NAND gates are used. You can name them as A, B, C, D, or 1, 2, 3, 4. So this is 1, 2, 3, and 4. So here output is connected here back to the input of this NAND gate. Output of this is connected here as the input of this fourth NAND gate. So this is a circuit diagram of a latch. So this latch is in set condition, means Q is 1 and Q bar is 0. This latch is in reset condition, means Q is 0 and Q bar is 1. So here these are the two inputs. So possible inputs are 0, 0, 0, 1, 1, 0, 1, 1. So here 1, 1 is not allowed. Now here two inputs of AND gate 1 and 2 are shorted. So this NAND gate behaves like a NOT gate. So if ESC input is say if both the inputs are 0, 0, this here you will get 1, 1, and here if it is 1, 1, it remains in the same state. Okay, now if you assume Q is 1 and Q bar is 0, so this 1 and 1, both the input of NAND gate 4 will be 1, and because of that its output will be 0. Okay, so here this 0 and this 1, so output of this NAND gate will be 1. Okay, so we assume Q and Q bar 1, 0, so it remains in the same state. If you assume Q as a 0 and this is 1, so in that case also it will remain in the same state. Let's see, suppose this Q is 0, so this 0 and 1, if you add, it is a 0 and then not 1, means here you will get 1. So this 1 and this 1, here you will get 0. So means if inputs are 0, 0, it remains in a same state. Output of latch or state of latch do not change. Okay, so that is represented by Qn. Here Qn means last state. Now if input is 0, 1, means if S is 0 and R is 1, if S is 0, R is 1, in that case here 0 will be available and here 1 will be available. So here 0 is available, it means that this output is 1. Okay, in case of a NAND gate, if one of the input is 0, then output will be 1. So this will be 1, this 1 and this 1. Okay, 1, 1, 1 and 0. So here 0 will be available. So it is getting reset. So in case of 0, 1, latch is getting reset, means Q is 0 and Q bar is 1. The next input is 1, 0. In case of 1, 0, latch will get set. Now let's see how. If this is 1 and this is 0, here 0 will be available and here 1 will be available. Means output of NAND gate 1 will be 0 and output of NAND gate 2 will be 1, because these two are simply acting as an inverter. So here now this third NAND gate, one of the input is 0, so that's why its output will be 1. So this 1 and this 1, here you will get 0. Okay, so means flip-flop is in set condition. So this is the thing, and 1, 1 is not allowed. 1, 1 is not allowed because here we assume that Q and Q bar are complement of each other. that will not be true if both are 1 1. So that's why 1 1 is not allowed. Now this is a SR latch circuit using NAND gate. You can have a SR latch using NOR gate also. So this is a circuit using NOR gate. Okay, so here just 2 NOR gates are required. So output of this is again given as a one of the input. This output is also given as a one of the input of this OR gate. So here also, if input are 0 0, it remains in a last state. Okay. So now if you assume last state as a this as a 1 and this 0, okay, so what will happen if 0 and this is again 0, so if you OR 0 and then not 1, so here 1 will be available. So this 1 and this 0, so here 0 will be available, so it remains in a last state. Okay. Or if you assume this 0 and 1, so here if you this 0 and this 0, so here 1 will be available, and 1 and this 0 will be available. Okay, so here whatever you assume last state, it will remain in that state if both the inputs are 0 0. If R input is 1 and S input is 0, in that case it will reset. Now see how. If R input is 1, this output of NOR gate 1 will be 0, and this 0 and this 0, so here 1 will be available. So if R is 1 and S is 0, it will reset. It will go to reset state, means Q will be 0 and Q bar will be 1. If this is 0, this is 1, then it will get set. Okay, if this is 1, so this will be 0. So this 0 and 0 here will be 1. So here in case of 0 1 it is getting set. Okay, and here 1 1 is not allowed, because in case of both are 1 1, this Q and Q bar will not be a complement of each other. That's why in this basic circuit both the input S and R is both the input as a logic 1 is not allowed. So this is a common truth table for both these circuits. Now this is a circuit of SR flip-flop, clocked SR flip-flop. So here see, if you compare with the SR latch and SR clock, so in case of SR flip-flop, okay, one additional input is there, that is a clock. Otherwise almost same diagram. So in this case, okay, if clock input is 1, then only these two will act as an inverter. If clock is input is 0, okay, so here 1 1 will be available, and then it will remain in the, and then state of this flip-flop will not change. Okay, so if clock is 1, that time these SR inputs are responsible for changing the state of the flip-flop. Okay, so here basically this is a level triggered flip-flop. So if clock is 1, if both the inputs are 0 0, okay, so here what will happen, 1 1, and then it remains in a last state as described here. If clock input is 1 and if it is 0 1, okay, if S is 0, R is 1, okay, so it will go in a reset state. So here it's 1 will be available, here 0 will be available. So if 0, then here 1 will be available, and here 0 will be available. So it will go in a reset state. Okay, similarly if 1 0, then it will go in a set state. And here also 1 1 is not allowed.